Hi kids. So we have often heard that a picture is better than thousand words. A visual aid leaves a longer effect on the mind of an observer. So in this video, we'll see how to represent statistical data with the help of graph. We'll see how to construct a bar graph, histogram, and frequency polygon. Okay, so let's get started. First of all, when I talk about a bar graph, okay, now with the help of bar graph, what we do, of course, we represent statistical data. We represent data or observation or variant with the help of bars, rectangular bars. Okay, the width of the bar when you are constructing is uniform. See that it is same. The height of the bar corresponds to the frequency of the observation or the variant. Okay, your y-axis represents the frequency, okay, and your x-axis, when you talk about x-axis, represents your observations. I'll take an example and we'll see. For example, suppose we have a mode of transport which students are taking to go to school. Number of students. Okay, you see that suppose they go by walking, they take the school bus, they use cycle, or they use the private car. I see number of students who are going by walking is suppose 40, taking bus is suppose 200, cycling is suppose 60, car is suppose I'll tell 100. Okay, these are the number of students who are using different modes of transportation. Now, how to represent this information with the help of bar graph? First of all, draw the axis. Okay, now along your x-axis, your mode of transport will come. Your mode of transport will come. Along the y-axis, this is your y-axis, number of student will come. So number of student or the frequency, highest is 200. So what I'm taking suppose 2 centimeter as 40 units. So 40, 80, 120, 160, 200. What I've done, scale is very important. Along y-axis, I've taken 2 centimeter as 40 unit. Okay, along x-axis there is no scale. Okay, now mode of transport, the first mode of transport is walking. How many? 40. So I'll leave a gap of suppose 2 centimeter. Then I'll draw a rectangular bar. See, rectangular bar of width suppose 1 centimeter. This width is 1 centimeter, sorry. Okay, a rectangular bar of width 1 centimeter, and this is my walking. Okay, then bus 200. So I leave again 2 centimeter gap. I'll make another rectangular bar of width 1 centimeter. See, frequency is 200. See, the width is same, So this is bus. Then I'll again leave a gap of 2 centimeter. Cycling 60. So between 40 and 60, between 40 and 80, we have 60. I'll again leave a gap of 2 centimeter. and I'll draw this bar cycling. Okay, see 60 is almost here. Okay, this was 40, this was 200, and the last one car is 100. So between 80 and 120 I'll leave a gap of 2 centimeter, and I'll draw another bar, whose height is of course 100. So this is my car. This is 40, this is 200, this is 100, and this is 60. This is 60 and this is 100. So what I've done, I've represented this statistical data with the help of bar graph. Okay, this contains rectangular bars. The space between each bar is same and the width of the bar is same. Clear? I hope you can draw this. We have done this in earlier classes also. So this was bar graph. Now let us see histogram. Now when we talk about a histogram are used to represent continuous grouped data with the help of again rectangular bars. Over here it has to be continuous first of all. If it is inclusive, the CI class interval is inclusive, change it to exclusive. It has to be continuous and then proceed. Rectangular bars, the width of the bars is equal to the class size, which of course corresponds to the respective class interval. Suppose 0 to 10, so the class size is 10. 10 to 20, again the class size is 10. That will be the width. There is no gap. There is no gap between the rectangle, between the bars, you can say. Okay, again the width is again on the x-axis. Okay, and the y-axis represents the frequency corresponding to the respective class. Okay, so remember these points. Let us see. I'll take a data. Suppose let us see one example. I'll take CI as suppose CI and frequency. Okay, CI I start from 150 to 160. 160 is continuous. Okay, exclusive. 160 to 170. 170 to 180. Okay, 180 to 190, and one more 190 to 200. Suppose this data was given to us. Frequency corresponding to this class interval is suppose 8, 7, 9, 5, 2. Now how to represent this data with the help of histogram? Of course we need two axes. Look carefully. Our x-axis and y-axis. Am I clear? Now x-axis represents your CI, y-axis represents your frequency. Okay, this is 0. Now our CI starts from 150. So what I'll do, I'll give a kink. Okay, and then I'll start from 150. Then suppose 2 centimeter I'm taking. 160, 170, 180, 190, 200. What I've done along x-axis, I've taken 2 centimeter as 10 unit. Okay, and along y-axis what I'll take? Along y-axis I'll take 1 centimeter as 1 unit, because the frequency the highest is 9. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let us see. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now corresponding to this class interval 150 to 160, the frequency is 8. So 150 to 160, this will be my breadth or the width of the rectangle. I'll make a bar 8 centimeter. The height will be 8 centimeter. See, so I got this, the first bar. The class size becomes the width and the frequency becomes the height. Then 160 to 170 is 7. 7 is over here. See, there's no gap. Okay, I drew another bar. 170 to 180 is 9. So 9 is over here. Okay, so again, so this is 9 over here. Then 180 to 190 is 5. 5 is somewhere over here. 5. Okay, and then 190 to 200 is 2. So 2 is over here. Yeah. So this is my histogram. See, there will be no gap between the two rectangles. Okay, the width of the rectangle is equal to the class size, okay, which corresponds to the end points of the class interval. Okay, and the height represents the frequency of the corresponding class interval. And see that it is continuous. And if it is not continuous, if it is inclusive, make it exclusive. We know, we have done a video on that. Okay, now let us see how to construct a frequency polygon. Now let us see how to draw a frequency polygon. A frequency polygon is a closed curve representing continuous grouped frequency distribution. So we don't draw rectangular bars. We have frequency curve over here. Frequency curve. And how do we get this? First of all, first step, get the midpoint of each class interval. Okay, that is lower limit plus upper limit divided by 2. Then plot the frequency of the respective CI corresponding to its midpoint. So at the midpoint, you'll plot the frequency of each class interval. Join all the point which represents the frequency. Okay, so you will get a frequency curve. We'll see with an example. Okay, now what happened? The end point, remember this is very important. That's why I mark closed curve. Don't leave it open. The end point, this is very important. The end point of the frequency curve are joined to the immediate you can say lower and upper class interval. What do I mean by the last statement? I'll tell you. Now this point we need to remember. Look at this case. First of all, this is not continuous. It is, we'll make it continuous. It's inclusive. We'll make it exclusive. CI. So first, see, we know how to make it exclusive or continuous. CI, we have done it. Just look over here. How to make it continuous. Now, 131 minus 130. 131 minus 130 by 2. That's the adjustment factor. So 1 by 2, that is 0.5. So we'll subtract 0.5 from the lower limit and add 0.5 in the upper limit. So it becomes 120.5 and this is 130.5, isn't it? Similarly, this becomes 130.5, 140.5. Okay, the adjustment factor is 0.5. We subtract from the lower and add to the upper limit. Okay, this is 140.5 to 150.5, 150.5, 160.5. There's 160.5, 170.5. It's continuous. 170.5, 180.5. Am I clear? And the frequency we know is given to us is 12, 16, 30, 20, 14, 8. First of all, we need to get the midpoint. So that is called x. Okay, lower limit plus upper limit divided by 2. So 120.5 plus 130.5, that's 251. 251 divided by 2 will give you 125.5, isn't it? Similarly, this becomes 135.5. Look over here. This is 271. This becomes 145.5, 155.5, 165.5, 175.5. Lower limit plus upper limit divided by 2. So we have the midpoint as well as the frequency plotted along the y-axis. I have frequency. Along the x-axis, I'll plot the midpoints, okay? The class mark. Now, frequency, the highest is 30, so I'll take 2 centimeter as 4 units, suppose. See, I told you, if the scale is not given, it's up to you, okay? 16, 20, 24, 28, 32. That's the frequency. Along the y-axis, I'll mark the midpoints. Now, it starts from 125.5. I'll give a kink. Okay, this is 0. Now, before this class mark, what will be our class mark? This is 125.5, so it has to be 115.5, isn't it? And after this, we'll have 185.5. We'll mark one class mark extra, okay? So I'll start with 115.5, then 125.5, 135.5, 145.5, 155.5, 165.5, 175.5, 175.5, and this is 185.5. Okay, now corresponding to 125.5, the frequency is 12. So 12 somewhere over here, isn't it? Okay, corresponding to 135.5, we have 16. So 16 is over here, corresponding to 135.5. Corresponding to 145.5, we have 30. So 30 is somewhere over here in the middle. Okay, so I'll mark it over here, see. Okay, 155.5, it's 20. So 20 is over here. Just mark. Okay. Then 165.5, it's 14. 14 between this 12 and this. Okay, now this is done. 175.5, it's 8. 8 is over here. So we marked the frequency. Now just join it with a straight line. Okay. The adjacent. That it is a closed curve. So what we'll do, join this ends. Okay, this one to the previous class mark, that is 115.5. This one, this next one. Okay, so this is your frequency polygon. Clear? Scale over here I've taken as 2 centimeter as 4 unit along y-axis. Along x-axis I've taken 2 centimeter as 10 unit. Clear? So keep it till here in this video. In the next video, we'll see some other chapter. Till then, take care.